tell me about this crazy 240 that you built.
Not that crazy, but I guess it is to some. This is a car I've had since, well, it's my first car pretty much, and it's electric. It's fully electric. It's battery powered, and it's a drift car, so it's meant to go sideways. It's meant to have a ton of torque in an instant, and that's what DC motors are perfect for. So I'm using an 11-inch DC brushed motor, torque immediately, and that's what drifting's about. You want to have that torque right away. You don't have to worry about slipping clutches and spooling turbos and all that. That makes it really difficult. So this is just a very simple, basic design. It's like the biggest power drill you've ever seen. You got your batteries, you got your motor, and a trigger in between, and that's about it.
So how many thousand RPM?
It revs up to 5,000 RPMs. They do make higher versions as well. It's going to be going up to about 9,000 RPMs with the next one. Voltage on this car is only 144 volts. It's a dozen 12-volt batteries, so it's not high voltage, but the current is ridiculous. It makes about 2,000 amps with a current for about 10 seconds. So the thing with electronics, most people don't really get it. You ask me what the power rating on this motor is, and I have to tell you it's only about 47 horsepower. But that's a continuous rating, so that's different. With electrics, you have to rate them so that you can plug them in, you walk away, and you leave them running for years on end. Like, think about manufacturing, think about trains. Like, where do we use electric motors? We use them where we need them to run forever reliably, and that's really, they should be in our cars. So this is like removing the engine and just having the biggest starter you possibly could in your car. And it works. It works really well. Now this particular car, it doesn't go far. It goes 50 kilometers on charge, but it only costs me about $1 to charge it up. So I can't complain there. The maintenance costs on it are nil. There's no oil filters, no belts or fluids. None of that is. When you're burning fuel, there's a lot that goes along with it that you don't really understand. And with electrics, I mean, it's really simple stuff. Anyone can build this car. I'm not an engineer. I'm actually trying to be a high school teacher.
So a science teacher, I hope.
Yeah, actually, physics, math, yeah, all that.
Excellent.
You want to see how I charge it? It's this thing, you've probably seen them before. It's called an electrical plug. Yes, it has 3 prongs. In fact, you could probably plug this in about, I don't know, 100 different spots within 100 feet of us. The electrical grid is probably the best infrastructure we possibly have. Now, what people don't really understand about electric cars is that they don't need any special type of electricity. Electrons are electrons. What they need is a certain charger or a certain ability to get the electricity. So the outlets that you're plugging into, that's what's really important. Now, I've chosen to go with the industry standard. Standard 3-prong, I can go and plug into any 110 outlet. It doesn't charge as quickly as it could, but it works for me. This is a short-range car. It charges up. My car takes a few hours to charge, maybe 3 or 4 if I completely discharge it. But when I drive my car, I might have to charge it for an hour to get it back to full charge. So it's really not a big deal. It all depends on what you're looking for. If you want quick charging, which is a luxury, it's not a requirement, it's a luxury. If you want quick charging, you do something like this. You can see the size of this charger. We'll go back and look at my charger next, but this is a big charger. This is probably one of the biggest chargers you can get for lead acid. My charger is 93% efficient, which means 7% of the energy that goes through it doesn't get to the batteries. So it turns out usually in heat. If you're on a regular 110 outlet and you charge for an hour, you'll get about 5 kilometers of driving. Of course, every car is different, so you can't say that about every car, but about 5 kilometers of range. If you're going to go for a big, like 20 or 30 or 40 amp circuit, that's a 50 amp. That's crazy. If you're going to go for something like that, you're looking at more like 30 or 40 or 50 kilometers of range per hour of charging.
So how long did it take you to convert?
No, don't ask me that. It's not something that you can go into a parts store and buy the shelf and bolt it in, buy it off the shelf. It's like you have to make everything. I mean, look at the car. It's all custom. Every little piece had to be fabricated for this particular car. Now, if you were to ask me how long would it take me to do it again, that's a better question. It would be a matter of days to weeks. Now, this car took me over a year to build, but that's because I was doing it as a personal project, personally funded. I'm not sponsored. I'm a private individual just trying to blaze the trail and show people what can be done. So it's not like a typical conversion. There's certain answers to those questions that just don't really apply. So if I was to do it again, if I had another stock 240 and I had all the components sitting on the floor next to it, it would be a matter of, well, install time. If I didn't have to fabricate anything, days. Like, it would be literally hours. You could just unbolt things and bolt it. Like, think about when I removed all the stuff, I didn't just take out the engine. I took out the cooling system, the exhaust system, the fuel system. All the combustion-related stuff comes out. There's a lot of it. Now I don't have to maintain or replace that. So to put it in there, I have a controller, I have batteries, and I have a motor. That's pretty much it. There's a lot of other little things here and there, you know. It's not just as simple as that, but for the most part, anybody can convert a car to electric. They can really do it. It's quite a simple task.